Hi everyone, welcome to GemChem. Now today's video is on atomic structure part 9, and here we will deal with angular parts of wave functions xi, and we will also see how shapes of p orbitals and d orbitals are being obtained. Now let us start. But before starting, if you have not watched the previous parts of atomic structure, please do watch it. I will give the link in the description box. It will be helpful. Now let us start. Now we have already seen that this is a Schrodinger equation and these two parts are the angular parts as seen here as y, and this is known as spherical harmonics. Now here the value of h is being given, that is, this is a capital theta, and the value of capital phi is also being given, and these two values are being obtained from quantum chemistry, and the quantum chemistry book which you can refer for these values is MacLeod and Simon. And let us start for pz orbital. If we want to see the shape of pz orbital, so what will be the shape and how can it be obtained? Now if we consider L equal to 1 and m equal to 0, we know the m values lies from 0, minus 1, plus 1, right? So 3 orbitals px, py, pz. So we will see for pz. This is the pz orbital. So the value of capital theta will be equals to C10 sine 0 theta d1 plus 0 by d cos, in bracket you should write 1 plus 0, just substituting these values in this equation. Right, now this will be sine 2 into 1 theta. Ultimately we get it as C10 d cos theta sine square theta. Now we will differentiate these terms and we will obtain it as equal to C10 d by d cos theta, and we have to break the sin theta in terms of cos theta, so 1 minus cos square theta, and ultimately the term comes to be minus 2 C10 cos theta. Right, now we will see for our shapes. Now consider if theta equals to 0 degree, then what will be the value of cos theta? If we consider, then the value of cos theta will be 1, and the value of this term, that is capital theta, will be equals to minus 2c1, right? If suppose value is taken to be 30 degree, then the value will be equal to 0.866. Again, if we take the value as 60 degree, then the value will be 0.5, and this continues for 90 degree, the value will be actually 0. Now we go to the next page, and if we take 120 degree, the value will be minus 0.5, and if we take 150 degree, the value will be minus 0.866, and for 180 degree the value will be minus 1. So if we plot the square, then we will get the dumbbell shape. Now let us see how we can plot. We plot actually capital theta versus the small theta. So this is our graph, and if we construct it, then this ultimately is like this. These will be two equal in shape, and our plots will be like this: here, 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 then here, then here, and also here, and this is the ultimate 0 point, that is, it passes from, actually it passes like this. It starts from here, goes here, and then comes here again to 0 and then goes here. So this is the way, and by plotting this we get the above curve, and it is a 2p curve, right? And if we include the effect of phi, then we get a 3D figure, that is, this is a 2-dimensional figure, and when we affect the curve with phi, capital phi, then the diagram will be like 2D, that is, this surface will be a 3-dimensional surface, this and this surface will be 3-dimensional surface, when we include the effect of phi. This must be clear. Now see that if this becomes two sphere, one will have a positive phase and one will have a negative phase. That is, this part may have positive and this part may have negative phase. And since phi and theta has no physical meaning, if we consider square curve of angular wave function, then the above spheres becomes dumbbell shaped, depicting the shape of pz orbital. Now we will see for s orbital. Now for s orbital, what are the parameters? Now for s orbital, it is L equal to 0 and m equal to 0. So we put the values in the theta functions equation and we get the value to be as C0, 0. And for all values of theta, it will be this constant value. So when we plot it, it becomes a circle in shape, right? When we plot it, it becomes a circle in shape. And it has same phase because circle is being continuum. So it will have a same phase. So what will be the shape? It will be like this. And at different points, it will have the same value from the axis. That is C0, 0. Okay. Equal distance, so it has a radius of this one. So if we include the effect of phi, then what happens? It becomes a sphere. From circle it converts to sphere. It is for this reason s orbital is spherical in shape. We know that s orbital is spherical in shape, not circle but sphere. So again, on affecting the theta value, we get a sphere, not a circle, right? Now we will see for px and py. Now basically px and py are formed by linear combination of spherical harmonics. That is, for p, we take L equal to 1 and m equal to plus 1, right? So we get y plus 1 here and 1 here and theta comma phi. Again, when L equal to 1 and m equal to minus 1 is being taken, it becomes like y 1 minus 1 theta and phi. Thus, on combining these two linearly, px is actually the function of 1 by root 2 y plus 1 theta comma phi plus y plus 1 and above is minus 1 because we are combining these two. So this theta comma phi, and for the other one py, it is equal to 1 by root 2 only minus function. First one is combined by adding and second one is combined by subtracting. So px and py are linear combinations of these two spherical harmonics, and these are complex, so we will not go into the shapes, but we will see for d orbitals. We will just see the functions and we will see the shapes, right? Now let us see for dz square. Now what are the spherical harmonics which are present here? We know L equal to 2 and m belongs to minus 2, minus 1, 0, plus 1 and plus 2. We have already seen magnetic quantum number, so we can see this. And for spherical harmonics, it will be y2 minus 2, y2 minus 1, y2 0, y2 plus 1 and y2 plus 2, right? Now for dz square, the combination is as y2 0 only, where L equal to 2 and m equal to 0. And for dxz, it will be equal to 1 by root 2, again linear combination. When two directions are involved, we usually take the linear combinations. So this is y2 plus 1 plus y2 minus 1. And for dyz, it will be 1 by root 2 y2 plus 1 and y2 minus 1. And for dx square minus y square, it will be 1 by root 2 y2 plus 2 and y2 minus 2. And for the last one, that is dxy, it will be like this. dxy equals to 1 by root 2 y2 plus 2 minus y2 minus 2. These are all obtained from quantum chemistry. Details in this level is not required. While dealing with quantum chemistry, we will deal these in details. But here shape, how shapes are obtained and what are the functions is most important in these cases. So now let us go for our shapes. Now if we draw the axes like this, now if we go for the shapes, now let us see for dxz we will start first. Okay, we consider this to be z orbital and this to be x orbital. On plotting, actually the plot will be like this. It will not meet the 0, right? And this will be like this. All will be equal in shape, though it is being distorted here because of writing. This will be with different phases and the angle will be 45 degree in between. Now for dyz. For dyz, same construction of axes, but the y will be like this and the z will be like this and our plane will be like this. This will be our plane of construction which will come towards us for the y plane, and ultimate drawing will be same as before, that is this one, and with different phases plus minus, and this will be dyz. Next we will see for dxy. So if we take the axes again like this, then on constructing it will be like this for xy plane, right? This is a flat plane that is coming towards us. So ultimately again on giving phase plus minus, plus, then we get in this plane, right? And this is our actually dxy, and we can also do for dx square minus y square, and it will be in this direction. Let us see, it will be in this direction along the axes, minus, plus, minus. And for dz square, ultimate one, it will be like this, dz square. If we draw the axes, it is the most easy one. We know how it looks. It is like this. Here one dumbbell, here one dumbbell, and one coming from out and going inwards. This is the circle. And one thing is important to know for this one is that this circle has negative charge and this one has positive charge or the positive phase, and this is known as torus of electron density along xy plane. Torus of electron density, and it is present along xy plane. This is important. So these were the shapes of p orbitals, d orbitals and s orbitals. Hope it was helpful for you. So thank you for watching. Do not forget to like, share, subscribe and comment.